I spent a fair amount of time this week. I don't know if it's a fair amount, but I spent some time this week and later last week, going through the major books, the books that I'm using for the Baby Rudin project, and then finding the representative theorems where they were, and then building what I think is kind of like a reference of sets of proofs and or just the theorem that I'm going to be studying because I want to get to the point where I do more problems. And I want to get to the point where I can do some of the proofs just off the top of my head, but without memorizing, by actually understanding the concept. And so this particular video is going to be the first one of a new playlist that's only going to be the theorems. I love counting, and so this one's going to get me to count to 20. So I put in the field axioms, the way Baby Rudin did it. So basically, the biggest sources for the theorems and the proofs have been Baby Rudin and Bardo and Scherber, but I have gotten some more others from Thompson, Bruckner, what I call TBB, a few from Wade. Yeah, I think so far. And I think at least one proof out of Abbott. So good representation there. Ordered field. So 1 is field axioms, 2 is implied axioms, 3 is ordered field, 4 is some order axioms, 5 is the complex field, just multiplying complex numbers. 6 is the triangle inequality. 7 is the well-ordering principle, for which I have a proof later. 8 is the inductive hypothesis. 9 is something about greatest lower bound and least upper bound, LEB, GLB. C squared equals 2, C squared equals 3, so there's a gap. The gaps in the rationals are the irrationals. There's a more general proof for this, and I may attempt it and maybe put it in as one of those. So that's 10, 11. Then 12, the Archimedean property. Then the proof that I was mentioning before for number 7, the well-ordering property. Then 13 is Q is dense in R, where you find that between X and Y there is a rational. Then the extended real number system. This is out of Baby Rudin. Then De Morgan's laws. This proof is out of Bardo and Scherber, number 15. But I want to redo this cleaner and better. I think even Hammock, the proof book, I may use for that. Then surjective, injective, bijective, also from Bardo and Scherber. Inverse functions, I forget where I got this, but I think this is precisely out of Bardo and Scherber as well. Then some more Bardo and Scherber, where finite and infinite, countable, uncountable, that's 18, the uniqueness theorem. And then more for Cantor's, countable, uncountable, the enumerable. Then 19 is about sets. Subsets, collections of subsets, open or closed, right? In this case, no, this is not the one. I need to get one that has open and closed. This one is just sets. And then the nested interval property. So those are the 20 theorems that I've gotten so far. And I'll just keep adding as I go through another round of problems and proofs.